Hello class, and welcome to section 7-8, which is going to be a recap about factoring, and we are going to now choose the best method for solving here. So over the course of chapter 7, or the second half of chapter 7, we've learned a lot of different ways to factor. So we're going to go through in this extra bonus section and talk about how we know which method to use. So in each section, 7.4, 7.5, 6, and 7, you've been looking at one specific type of problem. Most of the time when we actually have to use factoring, it's not going to tell you which of these methods to use. It's going to say factor, or you're going to be in the middle of solving a problem to find the side of a right triangle, or to do a number of other different things within a math context, and you're going to need to know how to factor. These are the 5 options that we have learned for how to do that. The reason this first part is in red is that this is your first step no matter what you are doing. You should always check to see if you can take out a greatest common factor. If you can, you're going to want to start by doing that. Difference of squares, this only works if there's 2 terms. So that was that a squared minus b squared situation. It only works with subtraction, and it only works if it's 2 terms. The perfect square trinomial, the x squared plus bx plus c, and the ax squared plus bx plus 3, or plus c, all involve 3 terms. So this is where the most confusion comes in, because there are 3 different options if there are 3 terms. This first one, with the name, you're looking for those perfect squares. So that's what we went over yesterday in 7.7. You're looking for those numbers that you can take square roots of. Then to decide between these two, it's a matter of whether there's just a plain x squared or whether there's a number in front of x squared. Whether you can just factor by looking at c, or whether you have to use a and c and do that box method. So for the rest of this video, I'm just going to go through an example of each of these types of problems to review what we have learned, and then you'll be doing a worksheet in order to decide, or excuse me, in order to practice choosing each of these different methods. Some of the problems will require you to use more than one technique. So you might have to take out a greatest common factor and then do a perfect square trinomial. Or you might have to do a difference of squares and then do it again. So it does not mean just because you have done one of these things that you are done with the problem. You might have to do more than one step to complete a problem. So on this first one, we're going to factor 12a to the 4th minus 16a to the 2nd plus 24a. If you want to go ahead and try these problems on your own individually by pausing your video, that's fine. Or you can go ahead and just listen to me explaining this. There's not going to be any questions during this video where it actually pauses for you. So you can go ahead and pause and try these on your own, or you can just follow along and listen. So when I'm looking at this, again, my first step is always going to be to factor out a GCF. So I'm looking and I'm saying, okay, between these terms, is there anything they have in common? They're all going to be divisible by 4. And I've noticed that they all have an a as well. So I'm going to go ahead and take out a 4a. When I do 12 divided by 4, I get 3. Take out an a. I have 3 a's left over. Then I'm going to go ahead in this one, and when I take out a 4, I get 4. And then I've got an a left over. And then plus, when I take out that 4a, I have 6 left over. At this point, we've taken out our greatest common factor, and I can see that we haven't learned about factoring anything to a 3rd power. So the only thing that I can do on this problem is use the GCF. After that, my trinomial here on the inside, we don't have any techniques for factoring that. So this is where you would stop. On this next one, I notice it's 2 terms. First thing I would need to do is check for a GCF. There isn't one between these 2 terms. Now, because it's 2 terms, I need to decide, are these perfect squares? I look at 121. Yes, it is. I look at 36. Yes, it is. So this is one where we can use that difference of squares technique, taking that square root of each of the terms, and then we have the one negative term and the one positive term as our factored answers. So again, difference of squares, two terms. It has to be separated by a minus sign. If this was plus, then it would be prime. You cannot factor, even if they are square roots, you cannot factor if it is addition instead of subtraction in a two-term problem. The next one we're going to look at is 196x squared minus 56x plus 4. Again, the first thing you're going to look at is, can you take out a GCF? As I'm looking at these, all of them can be divided by 4. So when I do this, I'm going to pull out the 4, and then I've got 49x squared minus 14x plus 1. Now we're left with a trinomial in the middle. I noticed from looking at the front and the back that those terms can be square rooted. So if I take the square root of 49x, I get 7x. If I take the square root of 1, I get 1. Remember, you have to check that middle term. 7 times 1 is 7x, and then we're going to double that, so that gives us the 14 in the middle. So your final factored solution is 7x minus 1 squared. Remembering that middle sign has to match the middle sign of your trinomial. Next one we're going to look at, x squared minus 14xy plus 48. First thing we look for, GCF. There is no greatest common factor. Now we're in the three-term case, so we're looking at trinomials. This front part is a perfect square. This back part is not, so we can't use perfect square trinomials. Now I look up front, and I have just an x squared up front, so we do not have to use the box. So that means I'm looking at that back term, which is 48. So I need my factors of 48. So 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. And I'm looking for the pair that can get me to negative 14. That pair is 6 and 8. So I split up my x squared, and then I'm also going to split up my y squared in the back. To get to negative 14 using 6 and 8, I need to subtract 6 and subtract 8, which gives me my factored form. Next one, again, checking for a GCF. I don't have one. Checking for perfect squares. 5 is not a perfect square. I have a number in front, so that means I'm going to go ahead and use that box method. So I start with 5 times 8, which is 40. So I need 1 and 40, 2 and 20, 4 and 10, and 5 and 8. I need factors that can get me to negative 6. That's going to be the 4 and the 10. So that's when I put it into the box, remembering that first term, that 5x squared, goes in the top, the negative 8 goes in the bottom. To use 4 and 10 to get to a negative 6, I'm going to have a negative 10x and a positive 4x. When I then pull out those factors, they have a GCF of 5x. To get from 5x to 5x squared, I need an x. To get from 5x to negative 10x, I need a negative 2. To get from x to 4x, I need a 4. Double check, negative 2 times 4 gives me negative 8. So my factored form becomes 5x plus 4x minus 2. Next problem we're going to look at, y to the 4th minus 81. We cannot find a GCF here, and we have two terms, so that means I'm going to check for difference of squares. The square root of y to the 4th is y squared. The square root of 81 is 9. So my factored form as it stands would be y squared minus 9 and y squared plus 9. This is where we now need to double check, see if there is another technique that we can use, because I still have a squared variable. When I look at this, I notice that this first one can be square rooted and that this second one can be square rooted. However, the second one has a plus sign, so this is as simple as it goes. But this first term, I can take the square roots again. So I end up with y minus 3, y plus 3, and then I still have that y squared plus 9 term because I could not break it down any farther. So again, sometimes you might have to use a technique and you might have to use it more than once to get to the final simplified answer. Last example I'm going to go through. I have 63x to the third minus 168x squared plus 49x. Again, we're going to start by looking for a GCF. I know 63 and 49 can be divided by 7, so I'm going to go ahead and check the middle. That also can be divided by 7, and they all have an x. So I'm going to pull out 7x, and that's going to give me 9x squared minus 24x plus 7. Now that I have pulled out my 7x, I'm going to go ahead and notice I have a trinomial. 9x squared can be square rooted. 7 cannot, so that's going to put me into the box method. So I'm going to list my factors of 1 and 63, 3 and 21, 7 and 9. I'm looking for the pair that can get me to 24, so that's going to be 3 and 21. I'm going to go ahead and plug into the box. I have my 9x squared from the first term and my 7 from the back term. Then I have a negative 24x and a negative 3x. Looking for my common factor, both of these can be divided by 3, and I can pull out an x. To get from 3x to 9x squared, I need a 3 and an x. To get from 3x, that should be a negative 21, not a negative 24. We have the 21 over here, the 24 is in the middle. So to get from 3x to negative 21x, I need a negative 7. To get from 3x to negative 3x, I need a negative 1. Double check, negative 7 and negative 1 give me that positive 7. So my final factored form being 7x times 3x minus 1 times 3x minus 7. So again, this purpose of this video was just to review all of the different potential factoring techniques and show you ways that you can use them to pick out which one works best in a situation. If you have questions about any of these techniques or how to use them, please let me know when you get to class.